One of the things that is important when we look at matter is to determine what are the properties of a specific substance that we happen to be observing. Now we can look at, and we call these things properties, and these are characteristics of a particular substance. And we can actually divide these into two major categories. So when we observe something for the first time, the thing we tend to focus on right away are what's called as physical properties. These are properties that can be observed or measured. Some properties can be measured. Without altering the identity of the substance. So for example, if we look at a piece of, let's say, a cube of silver metal, and we ask ourselves, what do we notice about it? Well, we'll probably make note of what color it is, shape, whether it's shiny or not. We may pick it up on our hands and say something about its density. Is it heavy? Light. And we may observe that it appears cool to the touch. Maybe we can observe its texture. Is it rough? Is it smooth? Is it slippery? Is it bumpy? These are all examples of physical properties of a substance. Some physical properties of substances require us to measure something about it. Okay? So for example, things that we can measure that are still physical properties, we can measure the temperature at which the substance melts, because it's still the same substance. If we're melting it, we're making it go from solid substance to liquid substance, but we're not changing its identity. Is it magnetic? We can hold up a magnet, and we can determine if it sticks to the magnet or not. Okay. We can measure the density, and that way we'd need to measure its mass and its volume, because density is mass over volume. We could measure its size, we could measure length, or anything like that. So these are physical properties that we can simply observe, and these are some examples of physical properties that we measure. Okay, this is an important one to remember. Anything like melting point or boiling point are sometimes confusing, because you have to remember that a change in state of matter does not alter the identity of the particles making up the matter. Okay? They're just moving faster, farther apart from each other. That's all that's happened. All right, so what are chemical properties? Chemical properties in chemistry, we're very interested in. Chemical properties describe if a substance undergoes a chemical reaction. Or not. So some examples of chemical properties, things like something being flammable, okay, which means that it can burn or explode. Okay, that's a chemical reaction with oxygen. We'll come back and learn about more specifically about burning and exploding and flammability when we come back and talk specifically about chemical reactions. Let's see. If you see something that says reacts with some other substance, that's an example of a chemical property. The term inert, I-N-E-R-T, inert means something doesn't react with much. Okay, substances that are inert don't seem to undergo chemical reactions with hardly anything. That's actually a very important chemical property. If you're if you're running a museum, for example, if you ever go to Washington, D.C., and you see the Declaration of Independence put on display, that's a really, really old document. Okay? And we don't want the inks to change or the paper itself, to break down or with all the stuff that's in the air. So they put it in a case, and they fill the case with a substance called a noble gas. And that noble gas doesn't react with the paper or doesn't react with the ink. So it basically acts as a preservative. It keeps it in a suspended state, so it doesn't do the normal deterioration over time. So having the substances that are inert are very important. In chemistry equipment, we often want equipment to be made out of inert substances. It'd be pretty depressing if you put the chemical you're trying to study into your container and then the container started to melt. That would not be very useful. Let's go back for just one moment to, there's one physical property that also tends to be very confusing to students. And that is solubility. I want to make sure I touch on that. What is solubility? Solubility simply means that something can dissolve. Right. Now, the reason it gets confusing is because things appear to look really, really different, like they might have chemically changed into something else when they dissolve. However, just to give you kind of a little picture here of what dissolving actually means. Remember we talked about, this is my little solid here. Remember we talked about, when we talked about states of matter, and we said that solids are in a three-dimensional orderly array, rows and columns, right? So imagine this is like a sugar cube. And the sugar cube is made up of little sugar molecules or particles, and they're all organized in little rows and columns, and they're three-dimensional. Now, when you put the sugar cube into water, what the little water molecules do is what they do is they come and they break off the different particles from the cube. So after a while, what we get here, when we see the sugar cube dissolving, is the water molecules or water particles are actually taking apart the three-dimensional structure. They're breaking it down into its little pieces. However, they are not melted. They are not liquid particles. Going from a solid to a liquid requires the addition of heat. Dissolving requires the addition of water, or what's called a solvent. A solvent is a chemical that can dissolve something else. Okay, so be real careful that you don't get confused with when solubility, magnetism, and changes melting point, things like that, tend to be the ones that students tend to misclassify as chemical properties. So chemical properties are pretty easy to spot because they talk about chemical reactions. You might use these types of words. Here's another good word you may or may not know. The word tarnish. Okay, that usually refers to reactions with sulfur, like silver. Sulfur is an element. Silver tarnishes, and it undergoes a chemical reaction with sulfur. Okay, and that's one thing it can do. It can tarnish. Okay, so now we talk a little bit about properties. Let's go on and let's talk about changes. Let's talk about physical change. Now, if we're looking at a sample of a substance, we can make it undergo a lot of different types of changes. Physical changes are ones that alter size and shape. But do not alter identity. So for example, if we take a sheet of paper and we crumple it, it's not the same size and shape as it was, but it's still paper. If we take it and we tear it up, it's still paper. If we rip it, it's still paper. Okay? If I take a block of metal, I break it, now I have two pieces. I've changed the size and shape, but it's still the same piece of metal. If I melt it, now it's liquid metal. It's the same thing, it's just in a different state. But I haven't changed it into a different metal. It has undergone a chemical reaction. Okay. If I shred it or flatten it, okay, you start to get the hang of these are physical changes. Okay? So we don't change the substance into anything else. Changes in state are the ones that are tricky, and students tend to tell me that they are chemical changes, but they're not. So what is a chemical change? These alter the identity of the substance. Okay, and create new substances. Okay, so what are some examples of those? Okay. If I take my sheet of paper and I set it on fire, it's not paper anymore. Okay. It becomes basically carbon. That's what it's mostly. If something rots, okay, like dead bodies and meat and food, things like that, start to break apart and do chemical reactions and chemical changes, and you get new stuff. So it smells funny, it looks weird, okay, a lot of changes there. Uh, Fermenting, that's the process of turning like grape juice into wine. Okay, and that actually, okay, so you're taking grape juice and you're turning it into wine, so you're changing it into something new. Okay, I used the word tarnish earlier. Okay, these are just some examples of words, but sometimes we just describe something changing into something new. Now, something that's very important for you to know, and you will have to memorize these. Sometimes when you look at a chemical change and you're not sure if it's chemical or physical. So these are some things to help you. The first thing, and this is very common when we see chemical changes, is there's a drastic change in color. Now, I'm not talking about adding something yellow and something blue and mixing them together to make green. That's not a chemical change. However, paper's white, but after it burns, it becomes black. There's a lot of chemical changes that occur that involve a drastic change in color. Okay, so something was red, now it's blue. Something was white, now it's gray. Those are changes of color. Things indicate that there's something new that is formed and it has a different color. Another one is you see an absorption or a release. I can't spell. A release of energy. Now, I'm not talking about like when you burn something up. Right? So if you start a fire, you don't have to keep holding a match to it. Once you hold the match, it releases energy on its own. Okay? So we commonly see change in temperature. Substances get a lot hotter or a lot colder without heating them or putting them in the refrigerator. Okay? They release light, like when you, like a fire releases light, flares, things like that. And like in explosions and things like that, or when you gases, things pop and crackle or make big booming noises. Those are all releases of energy. Some other clues is that it produces a gas. How you know that a gas is being produced during the change? One way is if bubbles appear. Others, if a new odor appears. Okay, so that's why, like we talked about rotting. When something rots, we know it's a chemical change because after a while it starts to smell bad. Okay, and odors are an indicator that the change is producing a new substance. It's a gas. A lot of gases don't smell very good. Okay, the last one's a little bit, this is the toughest one to remember because this is not a familiar word. If it produces a precipitate, and you say, well, what's a precipitate? If I take Okay, and this is dissolved substance A. Okay, so this has been a solid. It's been added to water. It's all dissolved. You guys know what dissolved substance looks like. Okay, and then I'm going to combine it with another dissolved substance. We'll call it B. This happens a lot in chemistry, and we'll do some labs to look at this. Okay, so when we put them together in a new beaker, we get a solid. This is called the precipitate. Okay? So precipitate is basically when two dissolved substances are combined and they make something that happens to be a solid. It doesn't dissolve in the water. Okay? So it falls down because the reaction when we put them together will be through the entire thing, the chemical change, and the solids will start to settle down to the bottom because they're heavier than the rest of the liquid up here. So that's called a precipitate. The word precipitate means to fall. Okay, so that's like rain precipitates, snow precipitates, hail precipitates. And so do solids that are created when two dissolved substances are put together. And sometimes we put dissolved substances, we don't get precipitates. That tells you that nothing really changed. But if you see a precipitate, there's a chemical change. So if you look at a change and you're not sure whether you should classify it as physical or chemical, picture the change in your mind. What does it look like? And if any of the four indicators are present, sometimes you see one, just one, sometimes you'll see several in a particular chemical change. But if you can visualize any one of these happening, you have to call it a chemical change. Now, one thing you have to remember is that, if I ask you later, which I probably will, to tell me the indicators of chemical change, you must include the word like change of color, absorbing energy or releasing energy, produces gas, produces a precipitate. Okay, just saying that color is an indicator of chemical change, that's not a correct statement, because I can say, look, the ball is red. Okay, I throw the ball against the wall or I chop the ball into a million pieces, the ball is still red. The color change hasn't occurred. If you just say color, the color is red, the color is still red. You have to talk about a change in color. So remember to, when you try to remember these, remember a full and complete explanation. Okay, now it's your chance to look at some examples of physical and chemical properties and changes and classify them.